Students will have a quiz on factoring on Monday. So when you come in, I'll give you a practice quiz. And then you'll do a quiz in the same hours. So just a reminder that today is the last day of the term, so everything has to be turned in by 3 o'clock today. So that includes makeup tests, homework, anything like that. All right, so today, what we're gonna do is not learn anything new. We're just going to put everything together and we're gonna learn, actually, we are learning something new. We are learning how to solve by factor. I did push that off till today. So we are gonna learn that, but that's just one extra little step. It's not a hard thing. And then the hardest part I think you guys are gonna find is that what's hard is trying to figure out what kind of factoring you have. And then did you factor it enough is another question you may have. So what we have is we have 1, 2, 3, 4, 5 different types of factoring that we have learned. And in all of the types, you have to factor out that greatest common factor if there is one, okay? So regardless how many terms there are, you always check for that. And then you check if there's difference of squares. And I wrote this yesterday that with difference of squares, it could be x to the second, x to the fourth, x to the sixth. I think that's as high as I would go on that. And then sum or difference of 2 cubes would either be x to the third or x to the sixth. So the one that you would have to kind of check between, if it's x to the sixth, then you would have to kind of look at the numbers you're given to decide, are they squares or are they cubes? Okay, so that's one thing that you would have to do. All right, then if we have 3 terms, what we are going to do first is factor out the greatest common factor. And then we do the box on that table, okay? And then if it has 4 terms, I was telling you guys yesterday, I don't think I give you any that you'd ever have to factor this out, and then we do factor by grouping. So that is how that will work. So here we have 2 terms. And with 2 terms, the first thing you're gonna do is check, can we factor something out front? Okay, is there something that goes into both of these? Yeah, what? A 3, is there a W we could take out? Yeah. So then what you would do is you'd think 3W times what gives you 3W squared, that's W. And 3W times what gives me 15W, that's 5. Now, like I said, one of the questions that you may have is like, did I factor this enough? If you get down to where there's just W, that's as far as you can go. If it's x squared or x to the third, then you do have to check that it's not like difference of squares or some or difference of cubes. But when it's just a W, you're done. Okay. Now this one, notice, has 4 terms, and that's what we did yesterday. And with 4 terms, you want to group the first 2 together and the second group together. And what you look at is what can you take out of that first part, okay? So what I have here is I have a W to the 3rd power in both, so I can take a W cubed out of each. And then I look at W to the 3rd times what gives me TW to the 3rd, that would be T. And then W to the 3rd times what gives me a negative 2W to the 3rd, that's minus 2. Okay, then when I look here, I look at what could I take out of this? And there's a 10 in here and a 10 in here, so I can take a 10 out and put a plus 10 there, so that'll remind you when you bring the final thing down that this will be W cubed plus 10. So we're taking a positive 10 out. 10 times what gives you 10T is T. 10 times what gives you negative 20, that'll be a minus 2. And we talked yesterday about the fact that this and this have to be the same. If they're not, you've done something wrong. So then we're going to write the T minus 2 down. And then we're going to write down W cubed plus 10, which is this and this. So kind of what's in front of both, you're going to write as one of them. It does not matter the order those 2 parentheses are in. Okay. Now this one has 2 terms again, and if you look at your flow chart with 2 terms, the first thing you do is check, can you take something out front? And with this, we can't. There's nothing that goes in the 16 and 81 besides 1. And then what you have to do is decide, is this difference of squares or difference of cubes? And what I had you guys write on here, ours is x to the 4th. These don't work for x to the 4th. So if it's x to the 4th, it has to be difference of squares. So if we go back with difference of squares, if you guys remember what we did, 1 was plus and 1 was minus. If this is x to the 4th, you put half of your x's here, half of your x's here. So I go x squared here and x squared here. So you put half on each side. And then to decide what goes in front of that, you think, what's the square root of 16? And that's 4 and 4. And then to go here and here, you think, what's the square root of 81? And that's 9. Now, again, like I said, one of the things you have to be careful of is that you've done as much factoring as you can. If it's an x squared and it's plus, there's nothing you can do with that because there's not a sum of squares. There's just a difference of squares. If it's x squared and it's a minus sign, you have to check if you can take it further. And how you do that is it would have to be a minus. Your power has to be squared or to the 4th or to the 6th. And 4 and 9 have to be perfect squares on that back of your little flow chart. 4 and 9 would have to be on there as perfect squares, and they are. So that means I can take this further for this. So I'm going to do 2 parentheses again. I'm going to do a plus and a minus. That's x squared. I do x and x. For the 4, I think what's the square root of 4? And that's 2 and 2. And then what's the square root of 9 is 3 and 3. And notice now I just have x's and there's never anything more I can do with just an x. All right. So now if I look at D, I have 2 terms again. And when you have 2 terms, what happens is you're going to factor out a common factor always if you have it. And if you guys notice here, I can factor a 2 out of this. So I'd go 2, and then 2 times what gives me 2r cubed, that's r cubed. 2 times what gives me 128, that is 64. Okay, then I have r to the third power. So if it's to the third power, if it's a plus sign, it's going to be sum of 2 cubes. If it's a minus sign, you would check if it's difference of 2 cubes. Okay, so we have a minus sign, so we're going to check if it's difference of cubes. How you check that is that your variable has to be to the third power or the 6th power. If it's minus, you have difference of cubes, and this has to be a perfect cube. And if you look on the back of your flow chart, 4 to the third power is 64. So 64 is a cube. Okay. And when I do these, what I do is I say, what cubed gives me r cubed? And that's r. And then I say, what is b? This is my b. What cubed would give me 64? And that you can look on your perfect cube sheet, and it's 4 cubed equals 64. Now, in that flow chart for the test, we were doing difference of cubes. So you can copy this down into the problem when you're doing difference of cubes. And all you're going to do is take the A and B and substitute them in there. Okay, so I'll copy that down. Oops. And the 2 does not get lost. That 2 keeps coming down, and it's a minus b times a squared plus ab plus b squared. And like I said, that's something that's just, you just have to copy that down. And then you just substitute r in for a, or in for b, wherever you see it. So a is r, b is 4. Then I have to square a, so that would be r squared. Then I have to multiply a times b, which is 4r, bless you. And then I have to do b squared. 4 squared is 16. So this is 16. Now, another thing that you can remember is when you do difference of groups, I don't think you'll ever have one where you can factor it further. Okay, so that's our answer. All right, so now we're going to talk about the last thing in this chapter. And the whole reason we factor is so that we can find our answers to an equation. And we talked in the last chapter that if you have an equation, what we really care about with an equation is where it crosses the x-axis, because that is the zeros, you can call it, the roots, you can call it, the x-intercepts. Those are the answers to this question. So if you graphed this and saw where it went on the x-axis, that would be the answers to this, okay? So what we're going to do here is we're going to factor this as much as we can, and then we are going to find what our x's or a's in this case would be. So the first thing I'm going to do here, I have 3 terms, and I want to take out anything that's in all of them. And if you notice, I have 3 A's here, 2 A's here, and 1 A there. So I can take 1 A out front, okay? And then I'd think A times what gives me A cubed, that's A squared. A times what gives me 9A squared. I'd need a 9 and an A. And then plus A times what gives me 14A, that would be 14. Equals 0. Now, if you're trying to solve, you know that you can factor this further. Okay, now on that cheat sheet, actually, we'll just use the box on this. So remember, if this is a squared, we put a squared here. If this is 14, we put that here and here. And then what's in front of the a goes right here. And you would want to think, what are two numbers that I can multiply to give me 14? And this is another thing you have to remember. If this is the middle term is negative and this one is positive, what that tells me is both of these are factors here are going to be negative. So if the middle is negative, the last is positive, both of my factors have to be negative. So can you think of two factors of 14 that are negative that would add up to -9? Yep, -7 and -2. And if you took -7 plus the -2, that is -9. So then what I would do is take the -7 and put it in one spot, and I put an A with it. And then I put a -2 in the other spot and put an A with it. And where I put those two doesn't matter. Okay, once I get to that point, I think what times what gives me a squared? That would be a times a. What times a gives me -7a? That's -7. A times what gives me this? That's -2. -7 times a -2 is 14. So that means I've done it correctly. Okay. So now I bring that a down. I have an a -7 and I have an a -2 equals 0. And what I need to do is find what a is. Okay. So basically what you would be doing is here is you would be setting a equal to 0. You would set the a -7 equal to 0. And you'd set the a -2 equal to 0. Okay. So this is already an answer. The a equals 0, that's an answer. This one, you just think of it as you're solving for a, so we add 7, and a would be 7. That's an answer. Here, we add 2, and our answer is a equals 2. Now, when you list your answers, you can do it like this. You could say a equals 0, 7, and 2. Or if you were doing it on a test and there was a blank, you don't even really have to say a equals. You could just say 0, 7, and 2. Those would be your answers. I'll explain to you a little quicker way of doing this. If you're doing this and you want to find what your 0 is, if this is a -7, when your answer is going to be the opposite of -7, which is 7. If this is a -2, your answer is going to be the opposite of -2, and it's going to be 2. Is that easy enough to get that? Now let's go down here. I have two terms. I have two terms. I always try to take out a common factor. There's nothing that goes into 4 and 121. So then I have to decide, do I have difference of squares or difference of cubes? And I have an x squared there. And x squared is going to be difference of squares, okay? So then what I want to do is I want to look at, okay, when I do difference of squares, I do my 2 parentheses, and this is a solve, so it's equal to 0. With difference of squares, you're always going to have a plus and a minus. If it's x squared, I do an x and an x. And then I have a 4. So I think, what's the square root of 4? And that's 2 and 2. And then for 121, I think, and you have this right there on the back of your cheat sheet. You think, what squared gives me 121? It's right here. 11 squared does. So I put an 11 here and an 11 there. Okay. So when you go to solve this, basically what you would be doing is taking 2x plus 11 and setting it equal to 0, and 2x minus 11 and setting it equal to 0. So here you'd subtract 11. And we'd get 2x equals negative 11. And then we divide by 2. And x would equal, you can leave it as negative 11 halves, as long as 11 over 2 is a reduced fraction. So I can leave that as negative 11 halves, or if you divided that, it would be negative 5.5. Here I'd add 11, and I'd get 2x equals 11. And then if I divide by 2, x equals 11 halves, okay, which again is 5.5. Now, if you like shortcuts, I'll show you a shorter way to do this so you don't have to show this word, okay? To get this number, when you have a number in front of the x, you take the opposite of this, which would be a negative 11, and you divide it by what's in front of the x. So you take a negative 11 and divide it by 2. That would be your answer. If you can reduce that fraction, you have to do that. Okay, so on this one, you take the opposite of this and divide it by that, which is 11 over 2. Again, you could, if you have, or if you can reduce the fraction, you do have to do that. Okay. Now let's look at C. This one is going to be x squared here, 100 here, 100 here, negative 29 here. And this is another one of those where the second term is negative, this term is plus. And what that tells me is my two factors have to both be negative. So when I think of two numbers that are negative, that multiply to give me 100, and when I add them, they'd add up to negative 29. 25 and 4. Negative 25 times negative 4 is a positive 100, and negative 25 plus a negative 4 is a negative 29. So one is negative 25, and then I'm going to put an x with that, and one is negative 4, and I put x with that. So then when I figure this out, this is going to be x times x. What times x gives me this is minus 25. X times what is this is negative 4. Negative 25 times negative 4 is a positive 100. So now I'm ready to do this. One of my factors is x minus 25, and one is x minus 4, and that's equal to 0. Okay, so can you guys use that shortcut way? What would my x be? Just a positive 25, you change the sign, and a positive 4. Now, as you're going through, just to point out, like I don't grade this. So if you start to get with the trinomials where you can skip a step, you know, or something like that, you don't have to, it's not like you have to do these two parts. This is for you in case you need it. But if you start to get good and can go right to that's great. So now if I look at D, I'm going to look at what can I take out front? And I can take out a 4. Okay. And then I think 4 times what is 4x squared? That's x squared. Okay. Then I think 4 times what is 64? And that's 16. Okay. Now I have two terms. Does that look like difference of squares or difference of cubes? If it's x squared, it's squares. So with difference of squares, that's when you do the two parentheses. One's going to be plus, one's going to be minus. If it's x squared, I do x and x. And the square root of 16 is 4 and 4. So what are your two x's going to be? The opposite of this is negative 4. The opposite of this is a positive 4. And you can write them together like that. That's absolutely fine. This one is factored by grouping. So we're gonna put these two together and these two together. Here you look at what can you take out front? I can take a 2 and an M. And then I look at 2M times what gives me 2MK, that's a K. 2M times what gives me negative 12M, that's a -6. Now, if you remember, we talked yesterday, if there is a third term in your factor by grouping that has a minus sign, I kind of cheat and I write the K -6 here because I know these two have to be the same. And then I look at what should go in front here, like what times K would give me a -7K, and that's -7. And then you can check, is -7 times a -6 positive 42? And it is. And then when we go to do the next step, the K -6 we bring down because that's our common factor. And then we write this -7. Okay. Now in this one, you're going to get two different variables. So you do have to specify the two variables. So in this one, I have a K and their K is equal to 6. You guys get that? And then here I have an M. What would my M be? Can you tell? To be the opposite of this divided by that. So a +7/2. If you feel better about dividing that and putting it at 3.5, you can, you don't have to. But when they're two different variables, you should specify them like that. Okay. So let's just look. We do have to do this one. So if I look at this one, can you guys tell something that I can take out front? An X, okay? So I take out that X, and then I think X times what is X to the third? That's X squared. X times what gives me 2X squared? That's the X. And X times what gives me -35X is -35. Okay? Now, here's the deal. So we have X, and then we're going to factor this equals 0. So we have two negatives, and when we have those two negatives, well, let's actually go to over here and do our table. We'd have X squared. This would be -35. This would be -35. And then this would be a -1. Oh, no, sorry. I made a mistake right here. There should be a 2 right there. X times -2X. So this is actually a 2. So you guys think of a positive and negative number that would give you -35. And when you add them, it would give you -2. Yeah, -7 times 5 would give you that. And -7 plus 5 would give you that. So this is -7, the X, this is 5X. For this, I'd go X times X. This would be -7 times X. X times what gives you 5X is going to be a 5, and -7 times 5 is -35. So one of these is X -7, and one is X plus 5. And bless you, the reason I wanted to show you guys this is sometimes when you factor, you will get a number just out front. So if this was a 2, let's say, you don't have to worry about that 2 as far as getting an answer. If there's a 2 out there and you're trying to solve it, you can forget about the 2. But if there's an X out there, then you have to set that equal to 0 also. So one of my answers is going to be 0 because of that X. Then what would this one be? a +7, this one would be a -5. But I just want to say, because you'll have some like this, if you have a 2 or a 5 or something like that out front, don't worry about it when you go to solve. But if it's a variable, you do have to worry about it. So let's see. Let's do one like this. So this one here, we have a 2x squared. We have -18, okay? And remember, when you have that 2 in front, you have to multiply those two to decide what your factors are. So 2 times -18 is -36. And we want those factors to add up to a +9. Anyone think of a positive and negative number that multiply to give you -36 and add to give you a +9? Like 1 times 36, 2 times 18, 3 times 12, 4 times 9. If one's positive and one's negative, which one would give us a +9? 3 and 12. And the 12 would have to be the positive one, because when I add them together, I want that to be a +9, okay? So one of these is going to be 12x, one's going to be -3x, all right? When that is the case, when it's 2x squared, one of these is going to be x and one's going to be 2x. And you're not really sure, but one thing I look at is I go to this row and I see, does 2 go into both of these? And it does. So that means my 2x would go here. My 2x can't go here because 2 does not go into 3 even. Okay, so this would be my x, this would be my 2x. Because I have to put a number here times 2x to give me 12x, and that would be 6. X times what gives me -3x, that's -3. All right, so now if I go over here, one of my factors is x plus 6. One is 2x minus 3. Now, x here would be the opposite of that, which is -6. X here would be the opposite of this divided by that, so a +3/2. You guys feel good about it? This one, you're gonna take out a 2, and then you have that 2 out front, and when you go to factor it, if it's just a plain 2 out front and solve it, you don't have to worry about that 2. Everybody okay then after I give you the assignment? So I believe I have this on for weekly Spotify, but I'll also put it up on. And on Monday, we'll do the practice quiz and the quiz, and then we'll go into chapter 3 on Tuesday. Justin, do you want to go up McCall and listen to the video? Or do you have? Yeah, either way, whenever you're done.